Sorry. All right. Thanks for the technical difficulties there. OK, so welcome to OCP 2018. My name is Badriddine Khessib. I'm a Senior Director for Firmware Development at Microsoft. So from the title, you can see we're going to talk about Project Olympus, and it says fulfilling the promise of open hardware. So in open software, today, and when I say it's an open software project, it's well understood. Essentially, what you do, you go download the software. You should be able to build, compile, build it, deploy it, right? So it's almost an end-to-end complete project. In hardware, it's not there yet. Okay, it's not. The story is not complete, and I'll take you through some of the issues and how we intend to solve them in the near future. So about 1 year ago, we announced Project Olympus. And Project Olympus is essentially, it's a comprehensive set of hardware. It's essentially an infrastructure project. It covers the rack, compute, storage, PCIe expanders, which hold FPGAs and GPUs, flash. It's open in the sense of we gave the specs, we gave the CAD models, we gave the Gerber, right? And we actually used an open design process there. So we collected lots of feedback from the OCP members and some of the big customers. So it's not just our Microsoft Azure requirements. It actually meets some of the requirements of our partners out there. So what is Project Olympus? There is a compute side of the Project Olympus. So it's a blade. It's one new blade, and it could be either Intel, AMD, ARM. So it covers all the CPUs out there. It's dual three-phase with battery. So it's a dual power supplies. It's dual phases, dual power feeds, and so which means it has 6 phases going in. Within the power supply, there are actually 3 mini power supplies so it's like 2 + 1 for failover in case one of the phases goes down. It's also can hold up to 8 NVMe M.2s, SSDs, and it can actually hold more than that. If you use the other, this is native. Natively, you can actually have 8 connectors for M.2s. But you can use a AVA card, which has been talked about this morning. You can see it also in the booth. You can add up to 16 M.2s if you want to. In addition to the M.2 native M.2 slots, you can have up to 3 full height, half length PCIe slots. It's by 16. And it supports natively 50 gigabit networking. Right. So this is on the compute side. On the storage, where is the storage? Here we go. So on the storage, we have two sets of designs, and you can see them in the booth outside as well. There is the very high density one, and there is a smaller one which has 12. But the overall theme of the storage is really it's modular. So you can plug and play and divide it and subdivide it. So we'll see here. So the one underneath on the bottom is a 12-inch hard drives. It's called a swap. So this is meant for small, cold storage type of workloads, right? On the top, that is the hot swap. It's 88 drives, and it's very configurable. You can divide it into either, you can treat it as one, so it will be 188 drives attached to one server, or you can divide it into 2 zones, 44 each, or you can divide it into 4 22 hard drives each. So that's on the storage side. The flash storage, we actually have it here. This is a CAD model, but we have the actual product outside on the booth. This is a 1U, and it can hold up to 1 petabyte. So it's 64 M.2s, If you use 16 terabyte M.2s, which are going to be here in the near future, you can have up to 1 petabyte. The hot plug is 16, it's divided in 16 units, as we call it stick or ruler, right? Depending on what terminology you use. There are 16 hot pluggable sticks. Each stick can hold up to 4 M.2s. So the stick you see on the bottom, it's 2 on each side, 2 M.2s on each side. All right? So the M.2s are not hot plug, it's the stick, the carrier. Now, you can use the EDSFF, or what's used, sometimes people call it ruler. You can use that. So it's compatible with the ruler or EDSFF. So this is on the flash side. Last year, we announced also the PCIe enclosure or expander, and it's for GPUs and FPGAs. It can hold up to 8 GPUs or 8 FPGAs. It's also, we can gang or cable multiple of this into a multi-chassis, up to 4 of them. So we can daisy chain 4 of these enclosures, and we can essentially support all the way up to 32 FPGAs or GPUs. Okay. All right, so this is very high overview of Project Olympus. So it covers storage, compute, GPUs, FPGAs, flash. What's missing? So when we say open here, let me show you. This is essentially what is hardware, open hardware project. An open hardware project, essentially, it includes multiple components. It's the hardware side, and we gave schematics, as I said before. We gave the schematics, we gave the Gerber, we gave CAD models, thermal simulation, and so on. It's all up there. You can go and see it. What's missing was the firmware. So there was no firmware like UFI, BMC, chassis manager. We gave the chassis manager because that we own. The reason there is no firmware there is not Microsoft did not want to donate it or give it away. The reason is there are a lot of legal contracts with some of the original firmware providers. So we license the UFI from certain vendors, we license the BMC from certain vendors, and we are contractually obligated to keep it in-house. We cannot give it away. For the security. So we have lots of in-house security things which we deploy internally. However, it's not applicable to the outside world. So what we wanted to do, essentially, we wanted to make sure we have a standard that everybody can adhere to, and we have an ecosystem there. So that's the missing components. So in the rest of the presentation, I'll go through some of the firmware components and the security components and explain to you how we intend to open it and solve it in the near future. So this is what we have today, right? Or as of yesterday, right? So we have only hardware specs, schematics, right? So I'll start with OpenUFI. So we actually worked closely in the last 12 months with Intel. So Microsoft is a joint development with Intel on a OpenUFI. So there is actually, for people who are familiar with UFI, and there is something called Tiano project. And it's supposed to be an OpenUFI. However, there is not really active community around it. But most of the code is there. So what we did, we actually took UFI, the Tiano project UFI source code, and we ported it on Project Olympus compute motherboard, right? And it actually boots. You can power cycle. It's decently reasonable and solid, right? So so as I said, we ADK based. So the components, if you look at the picture there, the green, the yellow, it's all out there. What's missing is the blue, which is the open source, the platform, things that make the motherboard tick, essentially the platform-specific code. That's generally always missing. The other part that's missing is the pink or purple. That's the Intel Silicon, which is the platform initialization. So you need special license from Intel. So working jointly with Intel, we actually released both the blue, which is the platform side of the EDK2, as well as the purple side. So today, if you go to the Tiano project website, go on the platform, you will see Mount Olympus. You also see the platform, the PI modules that are there. Okay. So these are downloadable today. If you have a Mount Olympus motherboard, you can actually download them, compile them, and install them and run. So sorry, the URL is missing here, but it's Tiano project. If you go look for Tiano, you go there, it's there. So feel free to download it, play with it, and give us feedback. In addition to the Microsoft Intel project, there is actually also an initiative that started in OCP, and Microsoft is part of that, so is Intel. And that is the open UFI, open firmware initiative, right? And the first project for the open firmware initiative is essentially to standardize make UFI more open. There is actually a Linux boot activity there. There is a UFI activity. So we want to make sure essentially the Linux boot and the UFI boot work together, and we make sure we open them. So the committee is already there. Several companies are there: Microsoft, Google, Facebook, Intel. There are other companies out there as well. So participate, provide feedback, and hopefully something will bear fruit in the near future on this front. BMC. So for the BMC project, it's the same story here. So actually, we started Facebook, Microsoft, Intel, Google, IBM. We started an open BMC initiative. The source code is actually now hosted. It's already there under Linux Foundation. Microsoft, so we have actually working model right now on the JBOF, which you will see outside, the JBOD, which you will see also there. So we are actually consuming it, and we are producing code, and the code will be donated as we donate those components, the JBOF, the JBOD as well. In conjunction with that, actually, we worked with AMI. AMI is a major BMC provider, American Megatrend, right? And we produced a AMI open source code for the BMC. It's based on the open BMC, but we are working, so AMI, we are trying to work with AMI and the rest of the open BMC to make sure we take this code into the open BMC. So it's open, the code is there today. You can go download it. It runs on Project Olympus. So if you take the UFI, which I mentioned before, under Tiano, you take the open BMC, you can actually customize it. You can build it, customize it, and upload it to Mount Olympus motherboard, and it should run. So I think these two missing puzzles from the motherboard, at least, it's kind of covered. All right, what's the missing piece? So the missing piece right now is security. And if you attended this morning, you'll see that Project Cerberus has been proposed, and we donated the basic specs for Project Cerberus. There is a committee that was established in OCP to take our proposal and specs and evolve them into a standard, right? So the committee already started. Major cloud and major CPU vendors are already there. Intel is there, Microsoft is there, Google is there, Facebook is there. So the major vendors and major cloud vendors are there. So what is Cerberus? Cerberus essentially is a hardware security. So it covers one aspect. So security is a multifaceted practice, right? It covers from a security development, it's a life cycle. There is the hardware, there's the infrastructure, there is the operational aspects. So, but Cerberus covers only the hardware side. This hardware thing is actually part of the drivers behind it, or the reasons why we had to do it. Obviously, I mean, it's something to do, nice to do. However, actually, there is a government standard which is called NIST 800-193. This is already accepted standard. Anything that the government buys and deploys internally has to support this standard. This standard essentially says, at the very basic, it says that any piece of firmware that is there has to be able to be protected from any attack, has to be able to detect any attack, and in case there is an attack or any intrusion, it has to be able to recover. So there are three pillars there. And any spec, hardware security spec, has to essentially fulfill these three requirements. If we look at the hardware today, so this is kind of a very simplified graph of a typical motherboard or typical server, right, today. So we mentioned there some of the components, BMC, UFI in the motherboard. Then you have certain peripherals, right? HPAs, you have NICs, you have FPGAs and M.2s, and depends on what configuration you can have more or less, right? It's all red, right? With the exception of the UFI. In the UFI, there is secure boot, but secure boot is not really, doesn't meet all the requirements, right? So something like secure boot card, it does protection, but there is no recovery, right? If you go to the BMC, there is none, no detection, no recovery. You cover all the other specs, FPGA, M.2s. Some of them cover some aspects, but in general, it's red, okay, to be honest. So there is no firmware security today. And this is a worrying, it's actually a very disconcerting. So that's why we proposed Project Cerberus. So we want the industry to essentially wake up and essentially take security seriously, right? So the hardware security, because hardware tends to be sitting at the bottom of the stack, but there are lots of attacks, actually, that can be leveled at the hardware level. And they are very serious attacks. They can range from denial of service to all the way to compromise customer data, right? So Project Cerberus, this is what you see there is a development card. It's essentially, we use it to just do some development internally and to test the protocols and to do certain development in-house. It's NIST compliant, so it provides those three pillars. It does protection, it does detection, and it does recovery, right? It's tamper-proof, so the chips there on that particular card, the root of trust in particular, it's tamper-proof, so you cannot attack it physically. It will essentially stop functioning. And it protects the UFI, it protects the BMC, it protects all the peripherals on the motherboard. Right. And it's CPU and platform agnostic, so it works with AMD, ARM, Intel, and any other CPU out there. Okay, so how do we do platform-level security, right? So the idea there is to essentially make sure that we have a very scalable scheme. So we're not going to have one root of trust that have to go and protect everything. So we have a master root of trust on the motherboard, and that master root of trust talks to the slave root of trust. So every device, something like a FPGA or GPU or an M.2 SSD, should behave as a slave root of trust. And there are certain conditions on the slave root of trust, right? And the role of the master is to challenge and to measure the slave. So when you boot, at boot time, the master will come up first, and then it will start interrogating the slaves. Okay, who are you? Give me your certificate. What's your essentially, you have to send them some data with it, signatures, right? And it will look at the signature and says, yep, I know you, you are accepted, or no, you are not. So it's very, very hierarchical and scalable by nature to make sure that it's not that it essentially, when you boot, to make sure the boot is fast, because if we centralize it in one place, then actually you have to go and the boot may take minutes or even hours, right? So it's very scalable, as I mentioned. And we are working, that's why it's not a Microsoft initiative. This is a whole ecosystem. This is a whole industry initiative. Because every component out there, somebody who producing a component has to be able essentially to give us feedback. work with the community, OCP community, and make sure he adhere to the Cerberus spec. All right. Next steps. So I think there are already committees formed for UFI, OpenUFI, OpenBMC, and for the Open Security Cerberus, which we call Cerberus. I invite all of you guys to participate, provide feedback, and make sure that whatever comes out meets your needs, right? So if you don't participate and something comes out that is partial and incomplete, I think we failed our job. That's right. There are presentations today and tomorrow that will cover some aspects of this. So today there is one at 4 o'clock by Mohan. He's going to talk about the UFI initiative. There is OpenBMC tomorrow, as well as Project Cerberus and the firmware about the Linux boot and the next UFI. So please attend those. Make sure you provide feedback and ask questions. Okay. All right. Any questions? Yeah, go ahead. There's phones on both sides. I mean, microphones on both sides.
Are there any plans to take the Cerberus technology out to other platforms other than compute? Like, is there any work going on with network platforms, storage platforms,
Yeah,
IoT?
that's a good question. So actually, you will see the JBOF that's out there. So by the way, so if you visit the booths, Microsoft booth, you will see. So the Cerberus chip or the root of trust should go on every computational device. Computational as not compute. It's switch, JBOF, JBOD, anything that has firmware on it and running, you can actually put it in and it should work, right? Yeah. So and our JBOF already has implemented the Cerberus project. Yeah. Any other questions? Okay. All right, guys. Thanks for coming. All right.